Hello friends, welcome to my YouTube channel Make Maharashtra. Will provide you the more educational videos which are related with the engineering field. Now the next point we'll see about the temperature effect on hydrodynamic bearing. Now it is very important to find out the temperature effect because in case of the sliding contact bearing, what happened, there are chances to create a friction in between shaft and bush as per the arrangement we have seen in the previous session. So we need to calculate the temperature effect here. Now few terms I'll explain. As I had explained you in the worm gear, there are the only two terms, heat generation and heat dissipation, that we need to follow how it comes, and after comparing that we'll get the temperature effect of anything. That is in case of here hydrodynamic bearing. Now I'll explain one by one. So rate of heat generation, we can say total heat generation is equal to power lost, as we know that PF indication we can give. So in this case, see, I have given here PF indication. So heat generation is equal to frictional torque into angular velocity. This will be the equation for the sliding contact bearing because of its velocity created by the lubricating oil. Velocity required for the lubricating oil. So heat generation is equal to friction torque into angular velocity. So friction torque is nothing but FWR. That is, torque is force into radius. So FWR divided by 10 raised to 3. So this will be the power lost into angular velocity 2 pi ns. So by comparing this, we'll get the power lost or heat generation in the system of the sliding contact bearing is 2 pi ns FWR divided by 10 raised to 6 kilowatt. This is in kilowatt. Clear? So F is coefficient of friction, W is total load applied at the center, R is the general radius, ns is the shaft speed. Clear? This is the heat generation. Now heat dissipation, how it can be dissipated. So that heat can be carried away from with the help of lubricating oil. So heat dissipation can be calculated mCp delta T. Very important. M is the mass flow rate of the lubricating oil. This is lubricating oil. Now mass density rho, total flow rate Q, Cp is specific heat of the lubricant, and delta T is temperature rise. So HD, heat dissipation, is equal to mCp delta T. So M is nothing but mass we can calculate by density into flow rate divided by 10 raised to 9. This will be the mass. We can easily calculate mass rho into flow rate divided by 10 raised to 9 in terms of kilojoule per second. Now Cp as it is and delta T will have to kept as it is. Therefore our heat dissipation equation is rho Q Cp delta T divided by 10 raised to 9. So don't get confused here, 10 raised to 6 is there because of it will convert it into kilowatt and here kilojoule per second. Therefore it will comes heat dissipation is Q rho Q Cp into delta T divided by 10 raised to 9. Just equate this two term. By equating this two term, we'll get one equation, and that is in terms of temperature range, and that temperature is delta T is equal to temperature rise in lubricating oil is equal to 2 pi ns FWR divided by rho Q Cp into 10 raised to 3 degree centigrade. So this is very important. So this will be the final equation for the temperature effect of the hydrodynamic bearing. If they have asked for the calculation derivation, you can use this steps: heat generation, heat derivation, dissipation, and compare it. Correct? By this way you can calculate temperature rise. So just revise the things which we have studied today. So first of all, the temperature effect, in which heat generation we have studied. Heat generation is nothing but power lost, and that can be calculated by frictional torque into angular velocity. That is 2 pi ns FWR divided by 10 raised to 6. It is in kilowatt. For same heat generation, heat dissipation, it will be mCp delta T. So mass is converted into density, that is rho Q divided by 10 raised to 9 into Cp into delta T. Therefore heat dissipation is rho Q Cp delta T divided by 10 raised to 9. By comparing this two, we'll get the temperature range 2 pi ns FWR divided by rho Q Cp into 10 raised to 3, that is in degree centigrade. This will be your temperature rise for sliding contact bearing. I hope you like this video. Thank you. Take it seriously, make practice more and more. This will be asked for write a note on or numerical. So the numericals in the next part. Thank you.